6.1, day 2. So we are going to continue looking at properties of exponents. We're going to quickly review the ones we talked about on Tuesday, and then learn just a couple more. And then again, it's just like some practice. Heads up, your homework for this is due tomorrow. And tomorrow we're going to start class by doing a little bit of a review. And then we're going to have a short quiz, just a very short little mini quiz on this, okay? Because rather than having a big chapter 6 test, we're going to have another little quiz, like a quiz, and then another little quiz before break, okay? Kind of like we did with chapter 5. So let's review the rules we learned so far. And I'd love to hear from people. Show me that you're actually in class today. Product rule. So we talked about the product rule last time. What that looks like is if you have something like x squared times x to the third. This is the product rule because we're multiplying our bases, right? X squared times x to the third. Does anyone remember what we do with our product rule, what we do with our two exponents? Who remembers what we do with the 2 and the 3 from last class? Or look at your notes. If you don't remember, take a look at your notes. Who thinks they remember what we need to do with the 2 and the 3? Or can look it up and tell us. Do we add them, subtract them, multiply them, divide them? So there is one that we will multiply them, Alex, but Nick was right on this one. We're going to add them. So our product rule, this is birds of a feather add together. We're going to add these together, and 2 plus 3 is going to give us x to the 5th. So with our product rule, and we can write this down below, you add your exponents. Quotient rule. Quotient is a fancy word for divide. So this looks like this. If I had maybe x to the third over x to the second, stack them and, does anyone remember? Stack them and do what? Add, subtract, multiply, or divide. This one is subtract. Stack them and subtract them. See how they're stacked one on top of the other? So the little way to remember this is stack them and subtract them. And you always do the bigger number minus the smaller number. So 3 minus 2 is 1. So this would be x to the 1. So our rule here is to subtract the exponents. Well, I can't really fit in exponents there, so I'm just going to put exp. All right, and then our power rule. That's where taking an exponent and raising it to another exponent. So that would be if we had something like x to the third squared. Raise them high and what? Very good. Raise them high and multiply. 3 times 2. Take our 3 times our 2. 3 times 2 is 6. Good. And these are our 3 main rules. And we just have some other little rules today that kind of help us continue our simplifying. So remember, birds of a feather add together. Stack them and subtract them. Raise them high and multiply. Good. All right, so we are going to just practice simplifying a few things. Now, these last class, we didn't get to see ones that had multiple rules at once, so we're going to kind of look at that a little bit today. So if you take a look at number 1, I see a few different rules happening here. Can someone tell me 2 different rules that are happening on this problem? I see 2 different things. Anyone, or can anyone tell me one of them? Yeah, very good. I see the power rule here because I see parentheses, right? And product rule right here because I am multiplying. I have my little multiplication dot. So I got to apply both of these rules here. Now, which one you apply first kind of depends on the problem, right? It's not quite like order of operations where there's one you have to do first. I have a tendency to work just from left to right, or if it's a fraction, from top to bottom. So if you take a look at this, let's look at this first part here. Go from left to right. I have in parentheses x to the third to the fourth, right? X to the third to the fourth. Take a look. Oops, sorry. Not trying to draw all over this, trying to erase. Take a look at your rules up above. If I have x to the third to the fourth, who can tell me what I need to do with that? What do I need to do with my 3 and my 4? I need to multiply them. This is raise them high and multiply. 3 times 4 would give me 12. So this is going to become x to the 12th times x to the second. So I took, here I'll color code this a little bit. I took this first part and I simplified it. That would become x to the 12th. So now I have x to the 12th times x to the second. So now if you take a look right up above, this is product rule. So product rule, this is birds of a feather add together. You add your exponents here. So if I want to add my exponents, Dallas, how do you think I would simplify this if I just need to add my exponents? No, well, I just told you, you just need to add your exponents. Oh, I would write it down then. Do you have a printer at home, Dallas? Oh, okay. Well, so remember, you can always just like write it out while we do it too, you know? Or see if there's someone who could pick up a packet from school for you. Gotcha. Okay. Well, so then for this, just take a look at this one, Dallas. So what we did here is we had x to the third to the fourth, right? So we took our 3 times 4 because this is raise them high and multiply. So that's x squared, x to the 12th. Do you see how we got that? Okay. Now here, this is product rule. So this is birds of a feather add together. So all we have to do here is add our exponents 12 and 2. So what's 12 plus 2, Dallas? 14, yeah. So this would just simplify to be x to the 14. Does that help a little? Okay. All right, so now let's take a look at number 2. Who can tell me 1 or 2 rules that you see happening here? There's 2 of them, but if you could name at least one. What are some things you guys see? Okay, I see the quotient rule. Thank you, Hayden. Someone else. Don't make Hayden carry class today. Somebody else. What else do we see? I see quotient because I see my fraction. What do you guys see on the bottom of your fraction? Jake Sanders, what do you see at the bottom of the fraction right here? You there, Jake? Aaron, what do you see at the bottom of the fraction? Okay. What's the symbol between those two things? the multiply symbol. Okay, so we have two different properties happening here. We have a fraction, right? That's division. So we have our quotient property happening, our quotient rule. And at the bottom here, because there's a multiplication sign, we also have the product rule happening. So here's what I like to do when there's something with a fraction and there's a little bit extra going on. I like to take a look at the top of my fraction, see if there's anything that can be combined. Then take a look at the bottom of my fraction, see if there's anything that can be combined, and then look at my fraction together as a whole. So for right now, just take a look at the top of your fraction. Can I do anything with just x to the 9th? Is there anything else up there? Can I combine them with anything? No. It's just the top is just going to stay x to the 9th. Then on the bottom, I have x to the 2nd times x to the 5th. So we're multiplying, right? So we're going to apply our product rule. Corey, how would I apply my product rule here? What do I have to do with my 2 and my 5? Good, I am going to add them together. So 2 plus 5 is going to give me 7. So now I have x to the 9th over x to the 7th. Now I just have one thing on the top and one thing on the bottom. So this is my quotient rule. This is stack them and do what? Stack them and, don't make me just talk to myself, guys. Stack them and what? Subtract them, right? Stack them and subtract them. So I'm going to subtract my 9 and my 7. Nick, how do you think I could simplify this when I subtract my exponents here? What should I get? Yeah, exactly. X to the 2nd power. Very good. Okay. And then last one of this one kind of has a lot going on. So we're going to do a little color coding here. I see regular old whole numbers, I see x's, and I see y's. So remember, regular whole numbers go with other regular whole numbers. X's go with x's. And y's go with y's. So keep your like terms together there. So first, we're just going to go through and just pair things together that are the same. So I see a 4 and a 2. Alex, what's 4 times 2? You there, Alex? Guys, I think like our class left us. Lynn, what's 4 times 2? 8. Thank you, Lynn. So we're going to take my 4 times my 2. That's going to give me 8. All right, now we're on to the x's. We have, oh, sorry, I don't know why that went all the way up here. My screen went all crazy. Okay, so we have x to the 3rd times x to the 3rd again. So x to the 3rd times x to the 3rd. What's 27? No, we just add our exponents. Well, I'm not sure how you got 27, I guess. Oh, maybe you did the 3rd, like 3 to the 3rd. That's what you did. Okay. So now this is just our product rule, Alex. So we're not taking 3 to the 3rd. We're combining x to the 3rd and x to the 3rd. And remember what we talked about on Monday? What that means here is you have 3 x's here and you have another 3 x's here for a total of how many x's? 6. So that's why you just add them. Does that make more sense now? Okay. That's what we would definitely do if it was like a regular exponent, like on a number, but since it's on a variable, we just have to add them together. So then let's look at our y to the 5th and y to the 4th. Remember, that's like saying we have 5 y's and 4 y's. So altogether, we're going to have how many y's? Bailey, what do you think? Y to the 4th and y to the, I'm sorry, y to the 5th and y to the 4th. Because this isn't a good sign with people actually being in class. Are we really gonna, like, the week before Christmas break, are we really all gonna have to turn on our cameras for attendance? With 1 week of virtual learning to go? Thanks, Dallas. Hey, Dallas, what's 5 plus 4? You guys have been sitting here, though. How many people have I just called on that didn't answer at all? It drives me bananas. Me too. Because then I can just stare at you and be like, Hayden, what's 5 plus 4? So, Dallas, since you're here today, what's 5 plus 4? It is, because here, this is like saying you got 5 fours, and we got, I can't even say it, I just said 5 fours. I got 5 Ys, I got 4 Ys. Let's talk about our last 3 rules. Or, I lied, last 2 rules. Hey, look at that. Only 2. And then we're really just practicing. And guys, make sure I stay on track. We get out of class at 10:25 today. Okay, that's like different bell schedule. I'm sure I'll space out and forget. Okay, so 0 exponent. This is a new rule. We got our 0 exponent. So remember, if you have x to the 1 or anything to the 1, doesn't that just mean you have one of them? So if I have x to the 0, how many x's do you think I got? If I have x to the 0, are there any of them? No. So we actually have this rule here. I don't know if you guys have a calculator with you, but if you do, if you have a handy dandy calculator, then what I want you guys to do is in your calculator, pick any number. I'm going to pick 5. And then put your little caret button and then 0. Like this. This is what I did. Okay, so any number you want to the 0. What did you say, Hayden? Yeah. And you get 1. Look at that. It's kind of like it cancels itself out, right? And isn't 1 like a placeholder number? If you multiply or divide by 1, it doesn't change anything. So it just kind of cancels out and becomes 1. So x to the 0 is just 1. Any number to 0 is 1. You can plug any number you want in here and put to the 0 and you get 1. If I put 432 to the 0 power, like this, I'm going to get 1. Anything to the 0 power is 1. So any non-zero number raised to 0 is 1. So for the 0, guess what? It's just 1. And it gets very tempting to say 0. It's not 0. Anything to the 0 is 1. So x to the 0 is again just 1. Anything to the 0 is 1. And then negative exponents, we don't want them. We don't want negative exponents. It's just a rule. So here's what you do. When you have a negative exponent, so any non-zero number raised to the negative, I can't read. Any non-zero number raised to a negative is its reciprocal. Remember, we talked about reciprocals when we did slopes. Reciprocal is a fancy way of saying flipped around. Okay, so if you have a negative exponent, you're going to take your number and you're going to flip it around. And our cute little way of remembering this is move it and lose it. We move our number to the opposite side of the fraction and we lose our negative. So for example, here, if I have x to the negative n, remember, can't I technically put any number I want over 1? Isn't that allowed? Like 5 is just 5 over 1, right? 7 is just 7 over 1. So x to the negative n is technically x to the negative n over 1. So to get rid of that negative, what I do is I move my number and I lose my negative. So right now it's on the top of the fraction. I'm going to move it to the bottom of the fraction and I'm going to lose my negative sign. So if you look over here, I have x to the negative 2. Remember, I can technically put any number I want on top of a 1, like make it a fraction. So I'm going to move my x to the negative 2 to the bottom, and I'm going to lose my negative sign. So it's going to become 1 over x squared. Here I have 1 over x to the negative 1. Now this time it's on the bottom of my fraction. So let's use our brains here for a second. If it's at the top of the fraction, I move it to the bottom, right? That's what I just did here. What if it's on the bottom of the fraction? Where do you think I need to move it? The top, exactly. So I'm going to move this x to the negative 1 to the top of my fraction, and I'm going to lose my negative sign. So that's going to be x just to the 1. Guys, am I allowed to put it as x to the 1 over 1? Can I do that if I want? Yeah, no, I can. You can always put a negative, or you can always put a 1 on the top of a fraction if you want. You don't have to though, but if it like helps you to like have that placeholder of just like, oh, I just need to flip this around, right? Then do it. But technically it just becomes x to the 1. All right, so let's try out a few of these. So first we're going to practice our 0 exponent rule. This is, at this point, this is the third time we've seen this. Take a look right up above. What's x to the 0 going to be? Yep, it is just 1. Anything to the 0 power is just 1. Good. Now here on number 2, I have 4x to the 5th, y squared, all raised to the 0. Huh. Well, that's interesting. So remember, this is like our raise them high and multiply rule, right? I have my parentheses. But think about this. Technically, won't I be raising 4 to the 0? Wasn't 4 to the 0 just 1? And then won't I be raising x to the 5th to the 0 and y to the 2nd to the 0? Okay. Well, guys, what's 5 times 0? 0. What's 2 times 0? 0. So isn't everything going to end up being raised to the 0? Yeah. So, and anything raised to the 0 is just 1. This is just going to become 1. Everything kind of cancels out because it's all raised to 0. All right, let's take a look at 3. In 3, we have some whole numbers happening. We got a 4 over a 2 and an x squared over an x squared. So I don't see a 0 yet, but we're going to have one in a second. So let's go through and let's just simplify. Remember, whole numbers go with whole numbers, x's go with x's. So I'm just going to go ahead and put my fraction bar because this is a fraction one, so just in case I need it. And what's 4 divided by 2? 2. Okay, so that's just 2. So I just need a 2 up at the top here because 4 divided by 2 is 2. All right, And then we have our exponents here. Remember, we stack them and subtract them, right? This is our quotient rule. So stack them and subtract them. Well, guys, what's 2 minus 2? 0. So won't I have x to the 0? Yeah. Do I have anything on the bottom of this fraction that's left over? No, so I don't really need my fraction bar if I don't want. If you want, you can just put a 1 on the bottom. But I now have 2 x to the 0. Okay. Well, what's x to the 0? It's just 1, right? So here, what's going to happen here is, first of all, you got to make sure you're careful here. Is the 2 being raised to the 0? No, the 2 doesn't have any little exponent on it, so it's just going to stay the way it is. The 2 is just a 2. But this x is being raised to the 0. And what's anything raised to the 0? Not 0, 1. Yeah, 1. So do I really need to worry about it anymore? No, because this would just be 2 times 1, right? Which is just 2. Another way to kind of think about this, guys, if you don't like doing it in 2 steps like that, if you have things on the top and the bottom of a fraction that match, like if you have 5 over 5, what's 5 over 5? 1. What's 7 over 7? 1. So what do you think x over x is? Still 1. What do you think x squared over x squared is? Still 1. So if you see things that match on the top and the bottom of a fraction, you can almost just think of it like they cancel out. Okay? So that's another way to do this if you don't like the way we just did it. If you take a look, don't you have an x squared on the top and the bottom of this fraction? Do we see that? Okay, so we can actually just like cancel them out and pretend like they're not there because they cancel. All right, if you take a look at 4 then. All right, so 4, we got to simplify some stuff, right? We got a little bit going on. So when you have a fraction, I always like to take a look. When there's a little bit extra going on in a fraction, I take a look at the top, see what you can simplify, take a look at the bottom, see what you can simplify. So let's look at the top here first. Remember, x's go with x's, y's go with y's. So don't mix your x's and your y's together. But aren't these all being raised to the second power? Don't I have my product rule, or I'm sorry, my power rule happening here? Do we see that? Do we see the parentheses? Hayden sees it. Do other people see it? Okay. You giggle, but I just don't know. All right, so I have my 2 outside here. Who remembers? Raise them high and multiply. So I'm going to take my exponents up here and multiply them by 2. So for my x, I'm going to take x to the 5th times 2. 5 times 2 is what? 10. So I'll have x to the 10. And then I have y to the 3rd squared. What's that going to become? Yeah, y to the 6th. All right, now let's take a look at the bottom. Is there anything that can happen there yet? Hayden says, no, I agree. I just see x's and y's. I can't do anything with them. I don't have any products. I don't have any things that match. So I'm just going to bring them over. X to the 5th. Sorry, my stylus off. Hayden, good observation. If I had a gold star, I would give it to you. Okay. But yeah, so Hayden noticed that don't the y to the 6 on top and the y to the 6 on bottom, don't they match? Do we see that? So those are just going to cancel. That's technically our 0 rule, right? 6 minus 6 is 0. They're gone. They cancel. But we still have our x's. This is our product rule. Stack them and do what? Subtract them. Stack them and subtract them. 10 minus 5 is going to give us x to the what? 5th. Good. Questions on that? No? All right. Moving on. We're going to practice some negative exponent stuff. We don't want negative exponents. We want to get rid of them. So this is move it and lose it. If you have a negative on the top of a fraction, and remember the top of a fraction, by what I mean by that is like see on number 1, there's not technically a fraction there, but can you put this over a 1 and make it a fraction? So if you see a negative in a situation like number 1, you're going to move it to the bottom of the fraction and lose your negative. If you see it like in number 2, where it's on the bottom of a fraction, you're going to move it to the top and lose your negative. So move it and then lose the negative. So if I have x to the negative third, remember that's the same as x to the negative third over 1. I need to take my negative and move it to the bottom and lose it. Lose it as in lose the negative sign. So if this needs to move to the bottom of my fraction, I'm going to put a 1 on top as a placeholder, and then my x to the third is moving to the bottom and becoming a positive x to the third. So basically I just flipped it around, right? Move it to the bottom, lose your negative. Here in number 2, it's already on the bottom. So where do I need to move it? If it's already on the, what, Hayden? Exactly, yeah. Yeah, and that's a good way to think about it. You're basically just flipping it around, right? So the x squared would move to the top and become a positive, and the 1 would go on the bottom. Do you have to, if it's on the bottom of a fraction, do you have to have a 1 there? No. Are you absolutely allowed to keep it there if it helps you? 100%. My guess is for ones like this, it would probably help you guys to have it there. All right, so then take a look at number 3. It's on the bottom, the negative's on the bottom, so it needs to move to the what? Oh, come on, guys, don't make Hayden answer again. I'm going to give Hayden all your grades. Well, no, I'm not going to give him all your grades. I wouldn't do that to you, Hayden. I'm going to give him all your points. Yes, so if you have this x to the negative 5th on the bottom, where do we want to move it to? To the top. I agree. We are going to move it to the top. What was that, Alex? Well, you know, it happens. So that's okay. So it's on the bottom, so we're going to move it to the top. So move it to the top, lose the negative, and then we'll have the 1 on the bottom. So basically just flipping it upside down and losing our negative sign. Now on number 4, I don't see a fraction, but I could make it into a fraction if I want. And now we're going to do the same thing. We're going to flip it, and we're going to lose our negative. So who can help me rewrite this one? Exactly. We're going to move this x to the 7 to the net bottom, make it positive, and your 1 is going to go to the top. Good. All right. Now, if you take a look at number 5 and 6, what's a little different about number 5? There's a 4 with it, right? So there's a few different things going on. Now, remember, if you have a whole number like that, it's its own thing, right? It's numbers go with numbers, x's go with x's, y's go with y's. So in this situation, you have this 4 here, and it's just a regular old 4. And then you have this x to the negative second. So in this situation, it is very tempting to take this entire thing and put it on the bottom of a fraction. However, does that 4 have an exponent on it? Hayden says no. I agree. This 4 does not have an exponent on it. The x does, right? The 4 does not. So is the 4 going to need to go anywhere? No, it doesn't have a negative exponent. We don't want to move it. So now what we're going to do is, since we have a negative exponent, we know we're going to have to move it. So let's make this a fraction first of all. And then let's go through this piece by piece. The 4, it has no exponent on it. It doesn't need to change in any way. It's just going to stay a 4 at the top of this fraction. But this x to the negative second, where does it need to go? Hayden said this. Someone else tell me, what does this mean? Yeah, what was that, Jacob? Yeah, it needs to go to the bottom. Exactly. This x to the negative second needs to move to the bottom and switch from a negative 2 to a positive 2. Yeah, exactly. So the 4 stays. It had nothing going on with it, but that x had to move. So now if you take a look at 6, we have an x to the third and a y to the negative fourth. X's stay with x's, y's stay with y's, right? Well, does this x have a negative exponent on it? What do we think? Does the x have a negative exponent? No. The x has a positive exponent. So does it need to move? No, it's cool where it is. It doesn't have a negative exponent. We can just leave it where it is. I'm going to rewrite it. Now look at this x to the negative fourth. Does that have a negative exponent? What do we think? I think it has a negative exponent. So where does it need to go? It needs to go, well, so you were right the first time. The x has a positive exponent, so it's going to stay. You don't have to change anything. But this negative exponent means we need to move this to the bottom. So it's going to move to the bottom and become a positive 4. So you're just moving that one little part over. All right. We got some mixed rules now, just 3 of them. We're going to try these out. All right, so take a look at number 1. We got x squared and then y to the third, all raised to the negative second. Which rule is this? Is this product rule, quotient rule, or power rule? Do you see a multiplication sign anywhere? No, but I do see parentheses. Parentheses mean which rule? Power rule, exactly. So if you go back up to your power rule, if we don't remember, power rule, we multiply our exponents. This is raise them high and multiply. So they're being raised high to the -2, so we multiply. So we're going to multiply all of our exponents together. So first, let's take a look at the x to the -2nd. I'm sorry, x to the 2nd. Can someone tell me what that's going to become? We're going to take our two exponents and multiply them together. Good. Yep, it's going to become x to the -4. Now let's take a look at the y's. I have y to the 2nd. I'm sorry, I have y to the 3rd. I'm raising it to the -2nd. What's that going to become? Yeah, y, what kind of a 6? -6. So y to the -6. Okay. But am I completely done? No, because am I allowed to have negative exponents? Not allowed. Okay. So I'm not allowed to have negative exponents. So I know I'm going to have to take these and I'm going to have to move them. So to kind of make it a little easier to look at, let's turn it into a fraction so we know where everything needs to move. So if you have x to the -4th, we can't have that negative exponent, so we want to move it and lose it. So we're going to take our -4, our x to the -4th, we're going to move it to the bottom and lose the negative. So I'm going to put my fraction bar again, and or I guess here I'll keep my same color coding so we don't get lost. Okay, so I'm going to take my x to the -4th and I'm going to move it to the bottom, and it's going to become x to the what? When I move it, it's going to become x to the what? To the 4th. Good. So that's going to become x to the 4th on the bottom. And now we have y to the -6th. Where's that need to go? Well, isn't it on top right now? Yeah, good. We're going to move it to the bottom next to the x to the 4th, and it's going to become y to the what? Very good. Y to the +6. And then technically, remember, this is kind of like flipping it over. So what's going to be on top now? Yeah, the 1. Exactly. Forgot my color. So we're going to keep our 1 moved to the top because we flipped this upside down. Our 1 moved to the top. Our x to the +4th is on the bottom. Our y to the +6th is also on the bottom. And that's our answer. All right, so now let's take a look at number 2. We have x to the 0 times x to the 4th over x to the -3rd. So there's kind of a lot going on here, so let's just look at it part by part. Again, when you have a fraction with a couple different steps, look at the top, see what you can do. Then look at the bottom, see what you can do, and then look from top to bottom. So let's take a look. Everything's an x though, right? So I don't have to worry about different variables at least. Everything's an x. So let's just take a look at the top part first. What can we do to simplify that top part? Anyone have an idea? What can we do to simplify x to the 0 and x to the 4th? Sure, I could add them. What's 0 plus 4, Hayden? Okay, Dallas. So, Hayden, what do you, I'm sorry? 4, yeah, 0 plus 4 is just 4. So we have x to the 4th on top. Exactly. And now on the bottom, we will. I'm just doing it in 2 steps, Alex. Yeah. Yeah, no, so you can go ahead and do that at once if you want. I'm just taking it in little steps so you guys can see what I'm doing. Okay, so yeah, right now with the x to the -3rd, You can't simplify anything here, but Alex is right. So actually, let's go ahead and do that since Alex pointed it out. We're going to go ahead and move that to the top. We don't want a negative exponent. If it's on the bottom, move it to the top. So when I move it to the top, Alex, what's it going to need to become? Good. So we're going to move it to the top, make it a positive 3. And then will there be anything left on the bottom? Yeah, you can just get rid of the line if you want, or put a 1 on the bottom. It doesn't matter. So now we got one more thing we got to do. Because now we still have two x's. We got an x to the 4th and an x to the 3rd. Well, we got to combine those. All together, if you have an x to the 4th and an x to the 3rd, what's that going to make all together? Yeah, exactly. X to the 7th. Good. All right, and then last one, number 3. We have x to the negative 4th, x squared, and x to the 5th to the 0. So, yes. 1025. So we'll be done after we after we finish this example. Okay, so let's go through and let's see what we can combine. Now, there's more than one good way to start this problem. Something I would do, though, is always look and see if there's something that cancels out. Do you guys notice anything that's going to cancel out in this problem? Yeah, there's a 0. There's an x to the 5th to the 0. So I'm actually going to go ahead and cancel it out. It's going to be gone because anything raised to the 0 is just 1, and I don't have to worry about it. So now I'm just left with x to the negative 4th and x squared. Okay, so what should I do with those two numbers? Should I add them, subtract them, multiply them, or divide them? So for this one, so go up to the top or go up to the front page of your notes and look at your rules. Is this, yeah, this is birds of a feather add together, right? This is your product rule, which means you add them. So we're going to have negative 4 time, or well, because, so I heard someone say multiply. That's probably because you saw them multiply here. But our rule when we multiply our bases is to add our exponents. So we're going to take our negative 4 plus 2. And can someone tell me what negative 4 plus 2 is? Negative 2. The number I just said. Oops. Okay, so now we have an x to the negative 2. But is it okay to have a negative exponent? It's okay in my final answer? We want a negative? No. Okay. So what do I have to do to turn this into a positive? Yes, we're going to turn this into a fraction. And we're going to move it to the bottom. We're basically going to flip our fraction around, right? So the 1's going to come to the top, and the x to the negative 2 is going to go to the bottom and become a what? A positive 2, good. So we'll have 1 over x squared.